Today, everyone, my name is Rose Nanquilada, and I'm here to present to you our research entitled In Silico Investigation of Thyroid Disrupting Activities of Sulfamethazine towards Thyroid Hormone Receptor Beta. To start with, emerging pollutants are compounds that are not regulated amidst adverse effects. These are substances such as those included in insecticides, pesticides, and antibiotics that have no or weak regulating policies that may pose grave effects to the environment and affected organisms. Sulfamethazine is a widely used sulfonamide antibiotic used for inhibiting bacterial infections in livestock such as swine, cows, and chickens. Amid its wide usage, it was found that only around 10% of SMG can be metabolized and the rest were to be excreted through urine and manures. Traces of SMG were already found on crops grown in infested land in 2007, and around 9,990 microgram per kilogram of SMG were also detected in dried manure sample in a separate study. Previous studies also revealed that about 90% of SMG-infused sediments or sludges are deemed as non-extractable but are still considered bioactive. Locally, there are already traces of SNC in the waters of the Philippines. This is evident to the fact that the Philippines is an agricultural country and we thrive mostly in agricultural livestock. The SMZ detected in Pasig River and Manila Bay accounts to approximately 23.8% and 21.2% of all investigated antibiotics, respectively. And in a separate study, the concentration of SMU found in the same location, including the Laguna Lake, were found in the range of 2.4 to 73.4 nanograms per liter. The toxicity of SNZ were previously studied and revealed to have significant effects on the levels of thyroid hormones as well as the growth and development of animal test subjects. It primarily causes thyroid-related diseases and abnormalities, such as the exponential growth of gonads in male chicks and and its effect in the innate defense mechanism of Ned tilapia against oxidative stressors. This research was conducted in silico, and the data selected and prepared were subjected to molecular docking via the Apodaca 1.1.2, and the data gathered were statistically analyzed. Visualization of complex was done via the BioVid Discovery Studio visualizer, and the pocket detection, medicine characterization, and the inhibition constant calculation were also done. Lastly, the validation of docking protocol were conducted. Characterization and visualization of resulting data showed that the anionic SMZ binding postcode 4912 and the neutral phenolic form of SMZ binding postcode 49.3 and 34.1 were the most optimum conformations, meaning that both anionic and neutral SMZ exhibited some similarities with known TR-beta antagonists in terms of their interaction with the thyroid receptor beta and the amino acid residues. Also, both anionic and neutral SMZ also bind to the TR-beta active site specific for GC24 and T3 binding, which were the natural hormone and agonist of the TR-beta. Significant amino acid residues such as adenine C17, C46, which were found in the ligand binding domain of TR-beta, were also observed to hydrophobically interact with the neutral SMC. This may mean that it has the capability to bind to the ligand or to disrupt the ligand binding process between the enzyme or the agonist and the thyroid receptor beta. The inhibition constants of each ligand were also calculated, and it was found that the neutral SMD exhibited the lowest inhibition constant amongst all the ligands tested. The phenolic forms of SMZ were also compared to its structural analog, which is the para-aminobenzoic acid. It is a known endocrine disruptor. The two compounds showed similar characteristics but were also found to have taken different pathways in binding to their respective receptors. And to sum it all up, it was concluded that the neutral SNZ is the most ideal phenolic form of sulfamethazine. Sulfamethazine may act as a blocker to natural hormone and agonist binding to Thyroid-Beta, and thus may inhibit biochemical function. It also has a lower inhibition constant than the known TR-beta antagonist. Hence, it has the greater inhibitory potency and is considered as a possible antagonist of the receptor. The conduct of both molecular dynamic simulation and vivo and in vitro studies by future researchers were also recommended to strengthen the foundation and the claim of this study. That will be all. Thank you all for listening.